How the surface of aluminum determines its corrosion resistance. The effective use of aluminium is sensitive to its potential reactivity under various environmental circumstances. Exposure of aluminium in many circumstances leads to the rapid production of an air-formed film of alumina. At ambient temperatures, the film is amorphous. It has limiting thickness of about 2.5 nanometers. At and above 500 degrees Celsius, both amorphous and crystalline aluminas are formed. Depending on the particular circumstances, the established film will react further with the environment. Thus, hydration of the outer surface of the alumina film can proceed to develop multi-layered films. The high affinity of aluminium for oxygen, resulting in development of alumina films. It also ensures that similar films will develop in damaged or scratched regions of the substrate. The figure shows some characteristics of air-formed oxide films. Defects of various kinds, generally called flaws, are present in the air-formed film on the aluminium surface. The total area occupied by such flaws is low, but processes proceeding at them largely determine the effective behavior of aluminium. What is the aluminum surface made of? The face-centered cubic unit cell. The unit cells are arranged in a systematic manner to provide a given grain. The material comprises many grains of aluminium of various orientations. Above the grains, the air-formed film is present. The surface is relatively rough from fabrication processes. Lubricating fluids result in organic contaminations at the surface. Impurities rolled into the surface provide regions of locally altered chemistry. Several effects can arise from alloying of aluminium. Alloying additions may be present in substitutional solid solution in the aluminium matrix. However, once the primary solid solubility is exceeded, second phase or intermetallic constituents will develop. For the age-hardening alloys, comparatively fine intermediate phases also precipitate. The common impurity elements in alloyed aluminium are copper, silicon, and iron. Iron has a very low solid solubility in aluminium. Thus, in commercial purity materials, iron is present as distinct second-phase material of relatively coarse nature. The surface nature of an aluminium alloy is far more complex than the relatively simple pure aluminium. Various features need to be considered, are listed in this figure. For a pure material, in single crystal form, the distribution of high energy or potentially active sites on the surface is relatively clear. Thus, in corrosion or metal dissolution, loss of metal ions occurs preferentially from kink sites at the surface or ledge sites as opposed to the lower energy terrace sites. However, for aluminium alloys supporting their air-formed films, any additional features arising influence, particularly the activity of local regions at the surface. The corrosion of aluminum is its return to the form of an inorganic compound. In low or high pH environments, the metal will corrode in a general or uniform manner. For alloys, local material and composition heterogeneities give rise to particular forms of corrosion. In situations where aggressive anions are present, for example, chlorides, localized corrosion of the metal proceeds, initiating at sites where the alumina film is breached and where healing is hindered. Thanks for watching. Remember to like, comment, and subscribe.